This is an FTIR spectrometer, and we use it to analyze pigments, binders, varnishes. The problem with real paintings is that they are varnished. So the issue is, can this piece of equipment tell the pigments when they are varnished? So I prepared this color chart with some pigments. We will look at some of them. And basically, for example, here we have ultramarine, the artificial form. The upper part is varnished with dammer resin, and the other part is without any varnish. We are going to test this spectroscopic method with two kinds of probes. We are going to use the one installed right now, that is the diffuse reflectance probe, and we are going to use also the ATR probe, the Attenuated Total Reflectance probe, this one, with a diamond cell. The difference about these two probes is that the depth of penetration of these two probes is different. With ATR, we just have few microns, 2, 3, 5 microns at most. With the diffuse reflectance, we have much more penetration in the order of hundreds of microns. So basically it means with ATR we can see just the first layer. So basically we will see just the varnish in this case. With the diffuse reflectance we will see all together. So we see the varnish, the paint, the support canvas, what is made with its own preparation layer. So will be a spectrum that will reflect all these things, all these layers together. So will be more complicated to analyze. On the other hand, the ATR will just see the upper layer. Okay, let's have a test. So we start to measure Prussian blue, it's over here, and we try the ATR probe first. So we remove the diffuse reflectance. Okay, and we insert the ATR probe. Okay, so we go into Prussian blue over here. So we start with the Prussian blue without any varnish. We put over here, we apply some pressure, and we start to measure. We started the recording. This is the spectra of lead white paint collected with ATR. So we drag and drop over here, and we see the features of lead white. So we see this sharp peak over here and this broad peak over here. Then this one is the peak from the binder. It was used acrylic binder. Now let's see what happens when we put some varnish over the lead white paint. So we have this one, ATR dammer, so dammer varnish. So we drag and drop over here. So let's see the spectra as a stack, so it's better to understand them. Okay, so we see now this red one, it's the spectrum of the lead white covered with the varnish. So we see that the most strong peaks of lead white are totally not visible. So not this one on the right, so these large bands over here, and also the small peak over here.
So we see a lot of peaks, but these are just the peaks of the varnish. And indeed, if we overlap the ATR spectrum of Damar, you see it's the blue one now over here. This is just a Damar over a bar of aluminum, so not other contribution to the spectrum. So we see the two spectra are totally comparable. So this is because the ATR is sensitive just to the first microns. So a varnish will be in the order of 100 of microns as a layer on the top of the paint. So ATR just can see the varnish. Let's see another example. So we delete all this one and we load Prussian blue. So this is the spectrum of the paint Prussian blue, and its main feature is this sharp and strong band at 2100, about 75 over here. Let's see the spectrum of Prussian blue covered with Damar. There it is. Again, we see that this strong band from Prussian blue is totally absent on the spectrum of the paint covered with the varnish. We see plenty of other peaks, but these are those of Damar. Okay, so now we move to see the spectra acquired with the diffuse reflectance probe. This probe analyzed an area in depth with a depth penetration of hundreds of microns. So basically we're gonna see a spectrum that has the combination, the absorbance bands of the varnish, the paint layer, and even the support. Okay, let's start with lead white paint. So we have here the spectrum of just the lead white paint. So we see this band over here, this band over here. These are typical of lead white. Now it's important to see also the spectrum of the support, which will play a role in this kind of examination. And indeed, we see this spectrum, these bands here at about 3000, and this one over here are present in the spectrum of just the paint itself. Let's see now the spectrum of the Damar, so the varnish on lead white. There it is. So basically, bottom line, even with this technique, with the diffuse reflectance, basically we cannot see anymore the spectra of the bands of lead white. Let's see this spectra as a stack spectra, so it's better. We use this bar so to focus on this first band. So you see this band that is typical of lead white, it's missing here in the spectrum of Damar on lead white. So the varnish basically cover it up. Also this large absorption band that we have of lead white is, well, it's barely visible here, but still you see it's not really the best method to analyze the pigment itself. What we see in this spectrum, varnish on the paint, is basically a combination of all the support. You see this one is the spectrum of the support, and we see it a lot clearly. So it doesn't work with lead white and for its bands. Let's see Prussian blue. So here we have, again, a spectrum of the support. spectrum of the Prussian blue paint and the spectrum of Damar on Prussian blue. Let's see those as a stack spectra, so it's better to understand what's going on. So first we have a look at the red spectrum, that is Prussian blue paint. So in this case we see this large feature, so this band over here, that is typical of Prussian blue. It's very strong, this absorption band, and when we look at the Damar on Prussian blue, we still see this band. So in the case of Prussian blue, we can still tell Prussian blue under the varnish because this absorbent is so strong. What happens with the diffuse reflectance is that the shape of the bands change a lot, because it's a technique very difficult in that sense, because there is a lot of interactions going on, so the spectra can change a lot. But in any case, the signal from Prussian blue is there, so since it's very strong, we can still tell that. So 1 point goes for diffuse reflectance. So for some pigments, but just a few of them, the strongest one, we can tell some pigments under the varnish.